Welcome to the Intel Edge Software Hub training. This video will cover the installation and running of the automated checkout reference implementation. In this video, you will learn how to integrate device services using sensor fusion and microservices with this automated checkout reference implementation. The prototype simulates the hardware components and user actions in a retail use case, monitoring the inventory and operating conditions of a retail cooler or cabinet. The software uses the following components. Sensors. Different sensor devices trigger events such as user authentication when swiping your badge, customer interaction with the machine such as opening and closing the door of the cooler, or a change in the machine temperature. These sensors are simulated in this reference implementation. Next is the middleware. We are using the Edgex Foundry, which is an open source component that sends messages back and forward from sensors to applications. And lastly, data reconciliation. The data is then reconciled to generate an inventory delta, finalize billing, or switch the machine to a maintenance mode. Time to complete is approximately 30 to 45 minutes. Most of the microservices are written in Go language, and these are the available software that we're using, Ajax, Docker, and Git. We're going to be performing curl commands and Intel OpenVINO to do the product detection. The target system requirements are Ubuntu 18.04 and the sixth generation or above of Intel Core processors with Iris Pro graphics or Intel HD graphics if you want to use the integrated GPU. Learning objectives. Use this reference implementation to build and experience an end-to-end prototype that simulates a specific retail use case. Learn how to integrate sensors and devices with microservices. And lastly, increase your understanding of the value of AI at the edge. The automated checkout reference implementation simulates the following three retail cooler scenarios. First, an employee stocks the cooler. Second, a customer purchases an item. And third, the cooler requires maintenance. For this video, we are going to be covering the first two scenarios. Scenario number one, an employee stocks the cooler. Simulation of the stocker's activity requires these sub-steps. Number one, swipe the badge. Once we swipe the badge, we will send information to the system and call the authentication microservice. Once the user is verified, the door is going to be unlocked. Once the door is unlocked, we proceed to open the cooler door, add inventory, and then close the door. After that, we will verify that the cooler's inventory has been populated, and next, verify that the cooler's audit log shows the transaction. For the scenario number two, a customer purchased an item, these steps are very similar. First, we swipe the badge, and again, it's going to authenticate the user and unlock the door of the cooler. Second, we open the cooler door, we remove some items, and then we close the door. After that, we will verify that the cooler's inventory has been altered, verify that the cooler's audit log shows the transaction, and lastly, we verify that the cooler's ledgers shows the transaction as well. Let's move on to the installation of the reference implementation. If you haven't configured and downloaded this reference implementation, please refer to the previous video or click on the configure and download button. Once you have the automated checkout reference implementation on your system, we can open a terminal and following the commands on the user guide. In this step, you need to enter the product key. You can find the key in your email or in the previous section for configuration and download. In my case, I have the key here in this document. I can just simply copy and paste. Next, the script is going to check your internet connection and the prerequisites. It will install all the different components that are required, such as Docker Compose and the automated checkout. At the end, you should see a success message and you can proceed to the next steps. To build the solution, let's go to the following path. Once we are here, we execute the following command, sudo make build. This command will call Docker to start building all the multiple Docker images. This process may take about 10 minutes depending on your internet connection. Once the building process is finished, you will see a message like this. This means that all the Docker images are already built and now we can run the automated checkout. To make sure we have all the Docker images necessary to run this reference implementation, we simply copy and paste the following command. And we'll notice that we should have 9 Docker images built. To start the services, we simply run sudo make run. We'll download Ajax Foundry Docker images and start all the microservices to run this reference implementation. Once is everything up and running, we can run the following command to make sure all the necessary services are running. As we can see here, the automated checkout microservices are up, so we can proceed to the scenario number 1. The very first thing that we need to check is if the maintenance mode is set to false. If for whatever reason it's set to true, we need to restart the application. So we just simply run this curl command and the maintenance mode should set to false. For visualization purposes, the computer vision inference service serves the post-process images over HTTP. We can open this URL on a new tab on your web browser, and it should look something like this. The following commands are time sensitive. This is because we have implemented security around this automated checkout solution. For example, if someone swipes their badge, gets authenticated, and unlocks the door, they have some time to open the door. Otherwise, it will unlock it. Also, if someone leaves the door open, after a certain time, it will set the cooler to maintenance mode. If you want to restart the solution at any point, you can just simply run the previous commands, make down to bring all the services down, and then rerun make run command. This solution has 3 different roles. We have the stalker role, customer role, and the maintenance role. Depending on which person is swiping their badge, they can perform certain actions to the cooler. Scenario number 1, an employee is stocking the cooler. This scenario simulates the stocking role and changes the cooler inventory. As we see here in the image, these are the actions that we are going to be performing. First, we are going to swap the badge as a stalker role. The system will authenticate this person and then unlock the cooler. This person now will populate the cooler with inventory and close the door, and after a certain time, the door will be locked. First, let's take a look at the status of the inventory. So we simply run this command on your console, and we will see here some data, the current inventory. Notice the units of hand for each item. It should set to 0 for all of them, like here. Next, let's take a look at the audit log. We simply copy this command and paste it to the console, and it should be empty. The ledgers should be the same. We copy this command and paste it to the console. The output should be empty as well for all of the accounts. As I mentioned, the following commands are time sensitive. So once we swipe the batch, we need to check the status of the lock. It takes about 10 to 15 seconds to unlock the cooler. Once the door is unlocked, then we can proceed to open and close the door with these commands. Let's start and swipe the batch as a stoker role. We, see, we simply copy and paste this command to the console, and then immediately we start checking the status of the cooler. You will notice that the lock 1 is set to 1, which means locked. We run this command several times until the status is set to 0. Now it's 0. Now we can open and close the door. We copy and paste this command. Enter. Now let's take a look at the URL. Now you see that the inventory changed and now is populated with some items. Now let's check the inventory by executing the following command again. Now let's take a look at the units of hand. Now we should see a change on them. As you can see, units of hand is 2 here. This one is 0. This one is 2, and so on. Moving forward, now let's take a look at the audit log. The output should be similar to this one right here. We have the car ID of the stock roll and the inventory delta. We copy and paste this command to see the audit log, and this is the output. Now, because this didn't create any transaction, it was not an actual purchase, if we check the ledger, it should be empty. Now we see empty values on the ledger. Scenario number 2, a customer purchasing an item. Now that the cooler's inventory has been stocked, simulate a customer swiping a card and removing one or more items from the cooler for purchase. The commands that we need to run for this scenario 2 are very similar from the previous scenario, but now we are going to be using the batch from a customer role. The actions that we are going to be performing for this scenario are the following. Number 1, we swipe our batch as a customer role. We will get authenticated and the door will unlock. Now we will proceed to take one or more items from the cooler and then close the door. The purchasing would be actual simulation. The first command that we need to execute is card swipe. We copy and paste this command. Now notice that this ID corresponds to the customer role. We copy and paste that command on our console. It's going to get authenticated and unlock the door. And to see that process, we see the status of the cooler. Now it's set to 0, so we immediately copy and paste the command that will open and close the door. Let's take a look at the inventory now. As we see, we have simulated a purchase from a customer. Now, two of the inventories have disappeared from the inventory. Now we can see here that the Pringles units on hand now is equal to 1. Moving forward, let's take a look at the audit log. And now we should see an entry for the customer, which is here. And now, because this was an actual purchase from a customer, a transaction has been created. If we query the ledger command, we should see an output like this. Now there is a transaction for the account number 1, which was for the customer, and we can see that product name was a Pringle and it was 1, and also a Gatorade and item count equals 1. For demonstration purposes, you can execute a scenario number 2 many times to simulate many purchases from a customer. Summary and next steps. This application successfully implements Intel distribution of OpenVINO toolkit and provides the base components for creating a framework to run a computer vision powered automated checkout. Extend the application further to provide support for different sensors and devices such as an RFID card reader or microcontroller board. To continue your learning, see the following guides and software resources. We have more technical details and documentation on this link. You can also learn more about Intel distribution of OpenVINO and EdgeX Foundry documentation. Thank you for your attention.